So, but there will be cases where they work well. I mean, obviously for legacy usage, you're going to use them just because that's the only thing that'll work, right? Because these new solutions, you have to write new code. But in addition, if you have complex transactional needs, it'll probably be the right solution because these NoSQL products have reduced transactional semantics, right? If you agree that the distributed transactions at a certain scale become hard, then, well, the solution we have is don't do them. So you can do certain, like, for example, in Mongo, you can do certain atomic operations, so you don't have 0, but it's a lot less. You can't just do arbitrarily complex transactions bigger than RAM, rollbacks, and all that stuff. But still, a very, very large set of use cases can be solved. There's enough there to solve a nice broad swath and get kind of speed and scale at the same time. So if you're building general ledger, use an RDBMS, right? And there would be 2 reasons. You need the complex transactions, and also the data model fit really well because you're fundamentally dealing with tabular data. And then finally, there's this NoSQL bucket. So what would you use this for? And we talked about this a little bit already. So one is for scale. The desire to horizontally scale is the original catalyst for this space. It's a big deal to do this, right? In terms of it's cost, right? We have to learn a whole new technology. It's not backward compatible. So there's a pretty big hurdle to clear to move to something new, right? But this imperative to scale is so important that people have jumped that hurdle, and it's pretty clear that this is going to happen. So at this point, because the usage is getting so high, the way computer architectures are going, it's really essential because at this point, clock speeds aren't going up. Right. So Moore's law still works, but what you're getting is you're not getting faster CPU cores. You're just getting more for the same price. So you're going to be able to get 1,000 CPU cores very cheaply, but you won't be able to get 1 fast core at any price. So we need somehow to make 1,000 cores work together at the data layer, and that's hard. So so these tools are going to be very useful for this scaling imperative. It's interesting, though. So the original catalyst was this desire to scale, but there's a side effect, right? So if we don't want to do joins because distributed joins are hard, okay, no joins, we have to pick a new data model because you can't do relational without joins, obviously, right? So then the question is, well, what is the data model? So given people are going to clear the hurdle anyway, there's an opportunity to innovate around the data model and try to pick something and create something that makes development easier. And I think you're seeing a lot of this in the space, and it's adding agility to programming in a number of ways. So I think there's really 2 benefits to this space. One is scale, and the other is agility, or another way to say that is just programmer productivity is higher. So this is my thesis on like if you think about kind of like a Gartner group, what will be in their reports 2 years from now. I'm hoping it's this, and this is my best guess at what's going to happen.
Very cool. You're talking about agility and talking about this opportunity for a new data model. Do you think that there's a need for some sort of standardization across the different platforms when we're looking at this sort of thing?
Yes, and there's not standardization yet, right? So I think you'll see more of that over time. There's a lot of different flavors out there. What these things have in common is generally light transactional semantics, and they're not relational, and they scale well. And then on other dimensions, like data model and various other things, consistency model, they vary. But some of the products, probably, I think on the one slide there were 6 NoSQL products listed. I think 3 of the 6 use JSON as the data they store. They're basically a document data model, and by documents we mean structured documents, not text documents. So 3 of the 6 are JSON. So there's a little bit of standardization kind of heading in that way, but not a lot yet in other realms like query languages and things like that.
But do you think, obviously standardization needs to happen. Do you think that eventually that's what we'll see, is that more of these things will start to kind of come together, the developers of the different theories, so that there can be something that's at least more standard, so you can move from one to the other if you need to, or since a lot of these are open source, if something, falls on the wayside, or, a situation like what happened when, Sun acquired, MySQL, and it, the fork started, if there's some sort of standardization opportunity there?
They'll become more similar than they are now. I don't know how far that will go. I mean, if we think in the early days of relational, right, there were multiple query languages. It wasn't just SQL, right? And then in the end, everyone just that was the standard, and everyone implemented SQL, right? So, so we'll see.
Very cool.
Just have a question. You talked about distributed joins earlier. Just have a question. Have you ever helped clients that ended up taking data and denormalizing it to spare themselves doing joins?
Have we had clients denormalize data to not do joins? I think a lot of people have kind of homegrown systems which were partitioned or sharded, like Facebook. And when you do that, I could take 10 or 100 MySQL instances and just partition my data among them, and then I could write a little code and that would work. But I can't join across the different servers, right? So you gotta pick some way to partition that I don't require to join across. So that's been pretty common. And then of course the issue there is, I mean, you can make it work fine, but it's just how much work do you need to do, and also how hard is it to add new partitions, right? So if I kind of split it up into eighths, if I want to add a ninth shard, is that easy or hard? So that's kind of how I think about it. Well, it's, in relational, when you normalize, you kind of break up the data, right? We take something that conceptually is one thing, like an order, and we break it up into 10 rows and 2 tables, right? Order and order line items, right? So we kind of took it apart, but and that makes sense in relational, but it's not necessarily the most natural way to think of the data. So in something like MongoDB, you would have an order document, it's kind of JSON style order document. It would have an array of line item objects within it, and that would be all together. So it's effectively pre-joined together. So that's kind of how you in Mongo you do actually useful work. Is that you create these fairly rich documents that are conceptually pre-joined together, and then you can get to a relatively large kind of complexity of operations. Right. Well, you could have a document that that has user 1 ID, user 2 ID in a collection, in a messages collection. Now, is that the optimal schema? I don't know. It depends on your use case. So what I find happens in this space is, in relational, there's sort of a correct schema. Like if you just tell me what's your entity relationship diagram, I can design the schema for you, and it'll be, about right. But in this space, what happens is there's still schema design, but it's very different because you design the schema for your bread and butter use case. It's not there's not an abstract correct schema. Right. So what happens is, because you sort of design your schema with a bias towards a use case, what happens is it's easy to do that use case, and it's extremely fast and scalable to do that use case. You can do other operations, but they're a little harder than they would have been otherwise, because I think one of the strengths of relational is ad hoc queries, right? If there isn't bias in the schema, I can do a query later that I a priori wasn't expecting to do, and because the schema is neutral, I can do it. But on the other hand, it's not optimized for a particular query either.
That's the, if I may, right, that's the big discriminator between the NoSQL and the RDB. I don't like using the word SQL to describe it, the relational database model.
Mm-hmm.
The relational database really shines with ad hoc queries.
Right, and I think that's that lower left quadrant, mostly the data warehousing quadrant. That's where you do the most ad hoc queries.
We've rediscovered the predecessor to relational databases,
Yeah.
which were statically defined to deal with high volume, known in advance queries.
Yeah, they're a bit like a more flexible hierarchical database, right?
Yeah.
So.
Or network data, or one of the other pre-relational models.
Right, and you can still link things that aren't pre-embedded, but you do it client side, right? You gotta, I get this object, and it's got a customer ID in it that wasn't in here. I can go load that customer, and and sometimes that works just fine. Now, obviously, it depends what you're doing, but